everyone, I'm Julia, and today I'm going to be walking you through a Shadowlink story problem. So let's get started.
So we're going to have a man who is 6 feet tall walking at a rate of 5 feet per second towards a light that is 20 feet above the ground. So we're going to draw ourselves a little picture here. This is going to be the light on this side right here, and then we're going to have a man. This guy is walking towards the light, so he's walking this way. All right. Oh, okay, so what we're going to do is this distance right here is going to be our x. We know that he is 10 feet away from the base of the light. And then our total distance from this to where the tip of his shadow, this right here is his shadow. So I'll make that a little darker so you can tell. So the total distance is going to be y, which means his shadow is simply y minus x. All right? So what we're trying to find here in part A is at what rate is the tip of his shadow moving? So that is going to be represented by dy dx. So this is what we're trying to find when x equals 10 feet. And again, that 10 feet is just how far away the sky is from the base of the light. So he's 10 feet right now, and he's walking in the opposite direction. He's walking towards the light, right? We said he's going this way. So that means dx dt is going to be negative 5 feet per second because he's walking towards light, meaning he started 10 feet away from the light, and every second he is reducing his distance from the base of that light. So we know that is the reason why dx dt here is going to be negative. Okay, so now as we're trying to figure out at what rate the tip of his shadow is moving, which is our dy dt right here, that's what we're trying to find. We are going to use similar triangles to relate 20 to 6 and y to y minus x. And you know what I'm going to do is I'm going to erase that 1 second so that I just give myself some extra room, as you'll see in 1 second. So 20 to 6 and y to y minus x. Okay, so now what we are going to do is we're going to work to isolate the y variable by first getting rid of the denominators. And the way we're going to do that is just by multiplying both denominators by on both sides. So, right? So this is just going to simplify down to we can cross out this 6 and we can cross out this y minus x over here because once they're on top of each other, that's the same thing as 1 over 1, so it cancels. So we're going to have 20 times y minus x set equal to 6y. And we can just simplify that, so that's 20y minus 20x equals 6y. Now what we want to do is combine our like terms. So I'm just going to have negative 20x on this side equals negative 14y. And then again, I just want to completely isolate the y. So I'm going to divide both sides by negative 14. So this equals negative 14. And then negative 14y divided by negative 14 is simply y. And now what I'm going to do here is just simplify. So y equals positive 10 over 7x. Because you're just getting rid of that negative there, because negative 1 over negative 1 just reduces to 1. And then 20 divided by 2 is 10, and 14 divided by 2 is 7. So now we have our equation that we are going to be deriving here. So now what we are going to do is take this equation, so y equals 10 over 7x, and we are going to derive. So what we're going to do is say dy dx equals 10 over 7 times dx dt. Lucky for us, we already know what dx dt is. dx dt, we just have that up here, right? So we're just going to plug that in right here. So we're going to say dy dx equals 10 over 7 times negative 5. All right, and that's just going to equal negative 50/7. And we're going to make sure to include our units right here, which is feet over seconds. And the reason you can know this is right up here, again, we have feet and, sorry, did not mean to do that. I meant to use the highlighter, is in feet per second. So we know that as we're multiplying this right here, it is going to be 10/7 times that -5 feet per second, which is going to result in our final answer right here being dy dx. Oh, dy dx. So the tip of his shadow is moving at a rate of -50/7 feet per second. And that's just going to be second right there. All right, so that's our answer to part A. So now we're going to keep this picture in mind right here and go, and I'm just going to scroll down and we're going to do part B. All right, let's draw this picture again just to give you guys another just base of what's happening. Sorry, let's make that a little bit more straight. Oh, sorry, guys. Okay, so this is going to be our picture. This is just the same exact thing. We've got, this is our light right here, and this is our man. He is walking. And again, we know that this is x, which equals 10 feet. This is the whole length is y, and this is y minus x, and that's just the length of his shadow right here. Okay, so for part B, what we're trying to figure out is what dy minus x dt equals. And again, that's just when x equals 10 feet. Okay, so we're trying to figure out at what rate the length of his shadow is changing, and this is, again, going to be written as dy minus x dt when x equals 10 feet, because we are trying to figure out what the rate at which the shadow represented by y minus x is changing per second, represented by the dt. That's just the per second, because it's the derivative of time. So by the distributive property, we can say that dy minus x dt is the same thing as dy dt minus dx dt, right? And then what we can do here is just plug in our knowns. So from previously, we know that dx dt is -5 feet per second. So I'll just rewrite that down here. So dx dt equals -5 feet per second. And we know that because it is a given, that is the speed at which the man is walking towards the base of the light pole, or yeah, the light. And then we know that dy dx, which is what we're trying to figure out right here, right? Dy dx and dx dt. We know that dy dx, because we just solved for it, is -50/7 feet per second. So we can use that right here and just plug in our knowns. So let's do that. So this equals -50/7 minus -5. All right. And now we're going to find a common denominator. So -50/7 minus, this is just to find a common denominator. I'm going to have the bottom be 7, which means I have to multiply the numerator and the denominator. So this is the same as 5/1. So just multiplying these both by 7 right there is what I would be doing. So just to make that a little bit more clear, we'll say -5/1, and I'm just multiplying these both by 7. Again, that's just how I'm getting this, which is going to be -35/7. Okay? And I'm going to scroll down a little bit. Sorry, guys. So now we're just going to simplify and say -50/7 plus 35/7 because we know that subtracting something from something else can be written just the same as subtracting negative 35 sevenths from negative 50 sevenths is exactly the same as negative 50 sevenths plus 35 sevenths, because subtracting a negative is the same thing as adding a positive. So we can continue and just add right here. So we're going to get negative 50 sevenths plus 35 sevenths, which is going to equal negative 15 sevenths. So we're going to subtract, and this is going to be our final answer. But as we know, with pretty much everything in calculus, you need units. So how we're going to figure out our units is we're going to look at the top, and we know that the numerator measures distance, right? Because that's this y minus x is a distance that his shadow is right here. So that's going to be measured in feet, because that is how distance is measured in this problem. And then the denominator is dt, which measures time. And in this problem, time is measured in seconds. So our final answer for part B is simply going to be negative 15 over 7 feet per seconds. All right, and that is how you solve a shadow length story problem.